variable speed motor control. In this lecture, we are going to talk about the need and advantage of electrical motor operating at variable speed. Variable speed pumps, an alternative to control valve for adjusting fluid flow is to regulate the speed of the machine, motivating fluid to flow. In the case of liquid flow control, this would take the form of variable speed pumps. In the case of gas flow control, it would mean varying the rotational speed of compressors or blowers. Varying the speed of the machine to control flow. Here one can see that by changing the speed of the motor, one can increase or decrease the flow of fluid through the machine. Letting the machine run at full speed and adjusting flow rate by throttling the machine's discharge. Here motor is running at constant speed. By opening or closing the throttling valve, one can increase or decrease the fluid flow through the machine. Adjusting flow rate by recycling fluid back to the machine's suction. Here by opening or closing the recycle valve, one can decrease or increase the flow of fluid to the process. Request. It is hoped that this lecture is going to be useful to you. Please press like. Please subscribe. In this diagram, all the three cases discussed are shown together. Flow control by machine speed control makes a lot of sense for some process applications. It is certainly more energy efficient to vary the speed of the machine pushing fluid to control flow as opposed to letting the machine run at full speed all the time and adjusting flow rate by throttling the machine's discharge, that is outlet, or recycling fluid back to the machine's suction, that is inlet. The fact that the system has one less component, that is no control valve, also reduces capital investment and potentially increases system reliability. Note: regulating fluid flow by using a throttling valve along with a constant speed pump is analogous to regulating an automobile's speed by applying varying force to the brake pedal while holding the accelerator pedal at its full power position. Electric motor drive. Modern power electronics provides the means to electronically control the speed of almost any type and size of electric motor using a device called an electric motor drive. DC motor drives. DC motor drives vary voltage to the armature and current to field windings of the motor. In general, DC motor speed is directly proportional to armature voltage and inversely proportional to field current. AC motor drives. AC motor drives vary the frequency of the power applied to the motor's stator windings. Because frequency is what establishes the speed of the stator's rotating magnetic field, which the rotor follows. DC motor versus AC motors. DC motors were once considered clearly superior to AC motors in variable speed applications, where high starting torque, that is torque generated at zero speed, was needed. The advent of sophisticated variable frequency drive (VFD) electronics, however, greatly expanded the useful operating speed range of AC induction motors to the point where one can do almost any task with an AC motor that used to be possible only with a DC motor. This is highly advantageous because AC induction motors are much simpler and more reliable machines than DC motors. DC motors use commutators and brushes to conduct electrical power to their rotating armatures, both of these components being subject to wear. AC induction motors convey power to their rotors by electromagnetic induction, not by direct contact, and so neither commutators nor brushes are necessary. In fact, the only bearing component in an AC induction motor are the bearings holding the shaft, which of course are common to all rotating machines and therefore not a liability peculiar to AC induction motors. Advantages of machine speed control. Following are the main advantages of machine speed control: soft start, precise speed control, regenerative braking. Soft start. Further advantage of machine speed control includes the ability to soft start the machine instead of always accelerating rapidly from a full stop to full speed. Soft starting electric motors greatly reduces the wear on machines, increasing their service life. Precise speed control. In applications such as conveyor belt control, robotic machine motion control, and electric vehicle propulsion, variable speed motor technology makes perfect sense as a control mechanism because the prime mover device is already, in most cases, an electric motor with precise speed control of that motor, yielding many practical benefits. Regenerative braking. In some applications, regenerative braking may be possible where the motor is used as an electrical generator to slow down the machine on command. Regenerative braking transfers kinetic energy within the machine back to the power grid where it may be productively used in other processes, saving energy and reducing wear on any mechanical brakes already installed in the machine. Why not control all fluid flows using variable speed pumping machines? With all these advantages inherent to variable speed pumps, fans and compressors as opposed to using dissipative control valves, one might wonder, why would anyone ever use a control valve to regulate flow? Why not control all fluid flows using variable speed pumping machines? Several good answers exist to this question. Variable speed machines often cannot increase or decrease fluid flow rates as rapidly as control valves. Control valves have their ability to positively halt flow. A stopped pump or blower will not necessarily prevent flow from going through. Some process applications must contain a dissipative element in order for the system to function. For example, let-down valves in closed-loop refrigeration systems. Split ranging may be difficult or impossible to achieve with multiple machine speed control. Limited options for fail-safe status. In many cases, there is no machine dedicated to a particular flow path. For example, a pressure release valve or a valve controlling water flow from a dam for us to control the speed. Next lecture. The time is now ripe to discuss about variable frequency drive (VFD). Very soon we may talk about VFD in a subsequent lecture. Request. It is hoped that this lecture is useful to you. Please press like. Please subscribe.